Hello everyone and welcome back. You've probably used arrays countless of times in your programs, and you've probably got a pretty good idea of how these things actually work. But did you ever stop and wonder what goes on behind the scenes? For example, what happens when you insert an element into the middle of an array? Or what happens when an array exceeds its capacity and gets too big? These are all great textbook interview questions. And in this section, we're going to solve these mysteries and more by quickly reviewing what the Humble Array is, how it works, and what makes it so special. Let's start with what an array is. Arrays are everywhere in software. We use them to solve puzzles, we use them to play games, we use them to transmit data, lots of data, which is why they are the most commonly used data structure we have out there and are pretty much a core part of every computer language. More formally, an array is a collection of elements, all of the same type, that can be set and retrieved via a continuous series of integers, or what are more commonly known as indices. These indices, or indexes, which in most computer languages start with the number 0, determine where in the array things happen. For example, to get the first element of our array, we would do a get with an index of 0. To set the second element of an array, we would set an index of 1. These indices and the respective operations are how we manipulate and control what goes into and out of our array. And that's basically how arrays work. It's all about the index. Now there are 3 things you need to know about arrays. 1, arrays can hold pretty much anything. Numbers, strings, objects, even other arrays. Not something we think about, just something we take for granted, but it's good to appreciate and know. Secondly, arrays are of a fixed size. You don't see this in Swift because in Swift, when we create an array, we don't specify its size. But in many other computer languages, when you initialize an array, you give it an initial size. So something just a little bit different with Swift, but something to note. Thirdly, arrays offer this unique ability to randomly access data. This may not seem like a big deal to you, but having the ability to randomly access any element in an array's data structure is big. That's what makes arrays so cool. Linked lists can't do this, stacks and queues can't do this, not even binary search trees, but arrays can. In fact, this is such a big feature of arrays that you might even call it the array's killer feature. Now let's quickly review the basic operations of how an array works, but also look at it from a different point of view, the relative performance of each of the operations, starting with get and set. The ability to get and set data at any location in constant time is what makes the array so great. No matter how big an array gets, if you know the index of the element you want, you can simply reach inside and get it in O⁻⁴ constant time. I used arrays for many years without really appreciating just how cool or powerful this feature was. But it's what makes the array the most popular data structure on the entire planet. It's also why just about every other computer language out there has them, and why they're so popular on interviews. Now there are 3 more features of arrays that you need to understand if you really want to get the mechanics behind how these things work. And those are insert, delete, along with how arrays grow and resize themselves when they start to get really big. Let's start with insert.